Imagine if I said that a telescope just floating a million miles away from Earth glimpsed something that might have been alien on a planet 4 light-years away. City lights, neither Hollywood nor science fiction, but actual information from the James Webb Space Telescope that shakes the fundamentals of what we believe to be possible. Right now, we're going to look at the astonishing discovery that may be the first sign to humanity that we are not alone in the universe. The James Webb Space Telescope has discovered something truly remarkable: light beams that appear to come from a pulsating city shining from a world 4 light-years away. This extraordinary discovery has rekindled our curiosity concerning the possibility of life on other planets. The telescope shifted its focus to Proxima Centauri b, the exoplanet closest to our solar system, and discovered an enigmatic flash. These signals could represent flashes of light, evidence of a high-tech alien civilization. Keep an eye out as we unravel this unsolved mystery that has enthralled both the public and scientists for centuries. The concept of life beyond our planet has generated a lot of excitement. However, a significant breakthrough occurred when the James Webb Space Telescope discovered abundant evidence that life may exist in other parts of the universe. While looking out over the vastness of space, this extraordinary telescope produced an amazing discovery that turned on the lights of a distant exoplanet, similar to the rising glow from alien cities, an enticing possibility that a successful city could exist in this faraway world. This idea has sparked a blaze of excitement and anticipation in the scientific community because it could be a significant revelation they've been waiting for, suggesting the existence of intelligent agents controlling civilizations in ways we are just beginning to imagine. 4 light-years away, engineers at NASA are perplexed as to how long these city-like lights have been visible, waiting patiently for our technology to advance to the point where we could locate them. David Kipping, an astronomer at Columbia University, has described the planet where these lights originated as intricate and one of a kind. Unlike most other rocky planets that convert sunlight into energy, the ultraviolet light from this exoplanet behaves in a completely different way because of the unusual way it interacts with its host star, Proxima Centauri. This amazing discovery, made by the James Webb Space Telescope, reveals the significance of the telescope in unlocking the unsolved mysteries of the universe. Its ability to detect wavelengths in the infrared was crucial in determining the unusual behavior of Proxima Centauri b, which is essential for comprehending the planet's atmosphere. Scientists have been prompted by this finding to plan additional research using the telescope to look into the air of this planet even more in depth, with the hope of finding out if it could sustain life. The Webb telescope's exceptional infrared sensitivity allows Proxima Centauri b to be observed thanks to its light. Numerous telescopes are unable to detect even a trace of light in the vastness of space. But the Webb telescope is very good at capturing even the tiniest flickers, making it the ideal tool for determining whether the enigmatic city lights of Proxima Centauri b actually exist. The telescope is capable of detecting light in any space as long as it fits within a very narrow frequency range, significantly smaller than the light produced by Proxima Centauri's regular stars. Proxima Centauri b has a dynamic relationship with its star, which profoundly affects its surroundings. Like many planets, it takes in a lot of energy from Proxima Centauri, where it is orbiting. Planets go through cycles of day and night, similar to those on Earth. The day is scorching hot, but it cools off substantially at night. The temperature fluctuations on Proxima Centauri b are vast, primarily due to its singular composition. For example, if the world lacks a climate with stable temperatures, the day and night could be extremely hot on one side and freezing cold on the other. This dramatic thermal variation is extremely intriguing to astronomers, providing useful insights into Proxima Centauri b's atmospheric makeup. As a result of the James Webb Space Telescope's capacity, scientists can capture images in the infrared, effectively investigate the planet's thermal emissions, and attain a more in-depth comprehension of its atmospheric properties. The Webb's orbit is interesting. It coincides with the orbital period of Proxima Centauri b, allowing researchers to observe the planet's sunlight cycles every 11.2 Earth days. In the event that Proxima Centauri b harbors an environment, the next logical step will be to investigate its chemical composition to examine whether it could sustain life. Detecting essential elements like oxygen, methane, and water vapor would indicate that the world has the capacity to harbor life. Studying. The light that enters the planet's atmosphere is a complicated process. While the James Webb Space Telescope excels at analyzing planetary atmospheres, particularly at measuring water vapor, methane, and carbon dioxide concentrations, it is not as capable of detecting free oxygen, an important indicator of biological activity. Despite this, the telescope can look for additional significant indicators, like ozone, which suggests a healthy environment supportive of life. Researchers continue to examine the data collected by the James Webb Space Telescope. As this search for distant worlds progresses, we are getting closer to addressing one of humanity's most profound questions. Do we truly stand alone in the universe? It's critical to acknowledge that the James Webb Space Telescope is only able to observe a select number of exoplanets that are fairly close to Earth. To investigate further, the study of planetary atmospheres will be key. Astronomers will use terrestrial observations, like the extremely ELT for the Large Telescope, which is set to the ELT will begin operations in 2028. Designed to offer a more comprehensive investigation of the surrounding structures of exoplanets, far away, supplying data that is more precise and clear on their capacity to assist the dying ideas that researchers have ambition. They have plans for future space telescopes, endeavor to create technologies that, keeping starlight interference to a minimum, better understanding of the planets in a manner similar to shielding your eyes away from the sun to get a better view. It is evident that these future telescopes will be able to concentrate on the dim light reflected by exoplanets, which make it simpler to analyze their atmospheres and assess their capacity to sustain life. However, this is no easy task. Stars are extremely bright, frequently overwhelming their planets that are adjacent to them luminosity, making it difficult to detect the planet's faint light reflect key to understanding their characteristics for dealing with this issue. Scientists are looking into a variety of one promising method is innovative. Technique calls for the use of coronagraphs are unique instruments that are inside telescopes to keep out light from stars, while allowing the light from the planet to pass through by manipulating carefully. Coronagraphs of light waves can lessen the star's brightness, which makes it easier to recognize in the dim lighting of exoplanets, are another exciting method. The star shade is the size of a huge flower. Spacecraft that can enter information gathered through the use of a telescope, a distance of tens of thousands of kilometers before, star shade will block starlight. It even makes its way into the telescope, making that the exoplanet's light is the only light this method reaches. The instruments could be particularly beneficial for observing planets in the zone that can support life liquid-rich regions of their star's water, and perhaps life may exist. However, these cutting-edge technologies require a high level of precision. For example, aligning a star shade needs to be done to the nearest millimeter fraction over extremely long distances. The obstacles must be overcome by innovations posed by space missions, like the requirement for energy efficiency in miniatures and the capacity to endure harsh conditions. Despite these space conditions obstacles, but also the potential benefits enormously effective in observing and studying the environments of exoplanets may result in the discovery of biochemical indicators of life's signatures such as water vapor or oxygen methane. In particular proportions, these molecules could indicate the existence of biological processes that produce convincing evidence that there is life beyond Earth. In addition, researchers are looking into ways to directly take pictures of faraway worlds in great detail in the future. Telescopes may be outfitted with sophisticated adaptive optics. that adapt for distortions brought on by the Earth's atmosphere or the manner in which the telescope itself, making the image sharper images when illuminated by stars, preventing these improvements from technologies, could make it possible for scientists to discover exoplanets and map their surfaces and investigate their environments. The creation of the next generation of space telescopes represent a significant advancement forward in our search for an answer to the most profound concerns of humanity are: we are the only ones in the universe to improve our capacity to observe those further away worlds that we're getting closer to, determining whether or not there is life beyond Earth has the potential to revolutionize our comprehension of our place in the universe. The direction in which space exploration and the search for life other than Earth is advancing at a rate never before seen as astronomers and scientists dig deeper into the enigmatic worlds of faraway exoplanets. The Space Telescope. James Webb is bringing about a new era of cosmic discovery. The information it collects is assisting astronomers make significant details regarding the structure, far-off population, and habitability worlds created by each new piece of information that brings us closer to a response. The ultimate inquiry is whether there is life beyond our planet, close by Centurion Bs. The process of discovery is only the beginning, could prove to be a significant turning point in our understanding of extraterrestrial life as the star that is closest to our own solar system. The planet. Proxima Centauri has been the focus of extensive research up to this point. The concept of finding something concrete, artificial light-like evidence of life or evidence of civilization appeared to be a far-off memory. The fact that such light has been picked up by the Webb telescope only increases our hope that one day could come into contact with intelligent beings inhabiting the universe. When something like this is discovered, both public interest and scientific curiosity, creativity that inspires new generations to look beyond the Earth's borders as the James Webb Space Telescope is still operational. Its observations, not just looking for artificial lighting, while also concentrating in the atmospheres of planets, their chemical makeup, and the circumstances that might support life's search for biomarkers like carbon dioxide or methane in the right concentrations are necessary for figuring out whether these planets could live as long as the Webb telescope's unique capacity to investigate these atmospheric components, illuminate the capacity of faraway worlds to possibly support life similar to Earth's. The most enticing feature of this. Our objective is to observe the beyond this point, the light from these planets' years, meaning what we see, to reach us. Each actually took place years ago today. A glimpse into the past is what discovery is. Cosmic time machine demonstrating the universe as it once was, as evidenced by the James Webb Space Telescope, is still operational. To pour in humanity is on the verge of collapse. Of a new era, one in which questions are once again considered impossible, such as the existence of finally alien civilizations, may answered.